equation of a straight line when you're given 2 points on the line using vectors. So let's jump into how we can do that. Okay, so equation of a straight line when you're given 2 points can be represented in 3 forms. And the first form that we would see is called the parametric form of vector equation. So what we're given here is the point A, okay, and we're also given point B. So point A is x1, y1, z1, and point B is x2, y2, z2. Now we are going to find or derive this line equation using these 2 points. And we know that we can have position vectors A and B to these 2 points. So let's see how that works. Now, we can say, let me illustrate this for you. Our point A is x1, y1, z1. And the point B is x2, y2, z2. So we can write OA vector as vector A, or it can be written as x1 I cap plus y1 j cap plus z1 k cap. Similarly, OB vector can be written as vector B, which is x2 I cap plus y2 j cap plus z2 k cap. Now consider the vector AP. Vector AP can be written as vector AO plus vector OP, or in other words, R vector minus A vector. Okay, vector R minus vector A. So we can write vector R as equal to vector AP plus vector A. Further, let's define vector AB. So we have this vector AB. Vector AB can be defined as vector AO plus vector B. Plus vector AO will be minus A. So it will be B minus A. So this is equal to vector B minus A. And since our vector AP and AB are parallel, we can write AP vector as a multiple of AB vector, T times AB vector. Alright, where T will be a scalar, or T belongs to R. Now, replacing this value of T, the TAB here, and further substituting the value of AB vector from here, you can say a vector R is equal to vector A plus T times B minus A vector, where T belongs to R. So hence the proof of how this can be expressed in this form. And the second form that we would see is non-parametric form of vector equation. Okay, so in this form we have to show, or the statement says that this is how it is written. Now again, to explain this, our AP vector is equal to how we explained it in the previous case, is nothing but R vector minus A vector, and our AB vector is equal to B vector minus A vector. Now AP vector cross product with AB vector will be equal to 0 vector, because they are both parallel. So substituting the values of AP and AB, we will get R vector minus A vector cross product with B vector minus A vector is equal to 0 vector. So that's how we can derive or show how this formula is obtained. Now the last one that we would see is called the Cartesian form of equation. So suppose P is xyz as given here, and A is x1, y1, z1 as given here, and our B is x2, y2, z2 as given here. So these are all position vectors, right? So now if we substitute the values of R vector, A vector and B vector, R vector is represented as x I cap, y j cap, z k cap here. Similarly, our vector A is x1, y1, j1 with I cap, j cap and k cap. Similarly, the vector B here. Okay. So if we substitute these values in our parametric equation, which is vector R is equal to vector A plus t into B minus A, with where t belongs to R. So if you start to substitute, and then if we compare the coefficients of I, j, k, we can derive at this formula. How did we get that? Let me show you. Now we know that our R vector is equal to A vector plus t into B minus A vector. So further we can say R minus A vector is equal to t times B minus A vector. Okay, now R vector is x I cap plus y j cap plus z k cap, and A vector is x1 I cap, y1 j cap plus z1 k cap. So when you say R vector minus A vector, your coefficient of I would be x minus x1, right? So similarly, on the right hand side, that's here, left hand side, x minus x1, okay, x minus x1. Similarly, on the right hand side, you have t into b minus a, right? So what is our b? B is x2 I cap and so on, and a is x1, y1 and z1. All right. Now b vector minus a vector, the coefficient of I cap would be b vector, which is x2, and a vector, which is x1. So it will be t times x2 minus x1. So you see that here. So we are equating, or we're saying that the coefficients of I cap of the left hand side with the coefficients of the I cap on the right hand side. You can get x minus x1 is equal to t into x2 minus x1. Similarly, you will get all of them. Now, if you bring this x2 minus x1 down, then it will be t is equal to x minus x1 divided by x2 minus x1. So you will get this as your Cartesian equation of a line passing through the two given points x1, y1, z1 and x2, y2, z2. Right? So from here we derive this. Further, from this above equation, we can observe that the direction ratios of a line passing through two given points x1, y1, z1 and x2, y2, z2 are given by, you see the denominator here, x2 minus x1. These are our direction ratios. Okay, so these are proportional to our direction cosines. So these are our directional ratios, and they are also proportional to, if you, instead of x2, x1, if you change it and make it x1, x2, y1 minus y2, z1 minus z2, they are still proportional. They are still our directional ratios. Let's try and do an example problem. So we are given the vector equation in parametric form of a line as R is equal to this vector plus t, this vector. Find the direction cosines of the straight line. This is our straight line. then the vector equation in non-parametric form of the line, and third is Cartesian equation of the line. So equation of a straight line in parametric form when you're given a point and a line parallel is, or vector is equal to vector A plus TB vector. Okay, now here our vector A is defined as 3i cap minus 2j cap plus 6k cap, and our vector B is defined as 2i cap minus j cap plus 3k cap. So what we can do now is, let's do the first part of the question, which is find the direction cosines. Okay, to find the direction cosines, you need to find the direction ratios. So since B is parallel to the line, so vector B, which is given by 2i cap minus j cap plus 3k cap, 2 minus 1, 3 will be the direction ratio of the line. So next, to find the direction cosines, see, these are the direction ratios. So if this is my x-axis, this is the point of origin, then, and this is my vector r. Since B is parallel to r, so let's take the vector B here and consider this as a right angle triangle. The ratio would be, which is direction cosine. If this is angle theta, for this would be this length here, adjacent side over the hypotenuse. So we need to find what is the magnitude of B. Magnitude of B is given by 2 squared plus 1 minus 1 squared plus 3 squared, and that's equal to square root of 4 plus 1, 5 plus 9, 14. So our direction cosine for will be 2 over square root of 14, which is adjacent side by hypotenuse, comma, minus 1 by square root of 14, 3 by square root of 14. Let's move on to the second part of the question, which is you need to find the vector equation in non-parametric form. Okay, so the formula for this is r minus a vector into b vector is equal to 0 vector. Now, what is our a vector? Let's replace them. A vector is 3i cap minus 2j cap plus 6k cap. Cross product with b vector is 2i cap minus j cap plus 3k cap is equal to 0 vector. So that's our solution for non-parametric form. Now for the last one, which is the Cartesian equation form. Okay, so we know that in this form the solution is x minus x1 by b1 is y minus y1 by B2 is equal to Z minus Z1 by B3. So here we write our vector A in the form of x1 I cap plus y1 j cap plus z1 k cap, and vector B in the form of b1 I cap plus b2 j cap plus b3 k cap. So we'll also see that our point is defined by, which is x1, y1, z1 is 3, minus 2 and 6. And the direction ratios are proportional to our B1, B2, B3, which is 2 minus 1 and 3. Okay, so the Cartesian equation will be of the straight line or call them the equations x minus, or x1 is 3 by b1 is 2. That's equal to y, or y1 is minus 2. So it's y plus 2 by minus 1, and that's equal to z minus z1 is 6 divided by b3 is 3, and that's our answer. Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.